Dear students, today I will discuss with you some important MCQ from the chapter Atomic Structure. First question, what will be the ratio of the wavelength of the first line to that of the second line of Pascal series of hydrogen atom? So question number 1, see what will happen. 1 by lambda 1, the Pascal series starts from N1 is equal to 3. Okay, N1 is equal to 3. So first series N1 3, N2 is equal to 4. Second series N1 is equal to 3, N2 is equal to 5. Okay, according to you have to do. So R 1 by 3 square minus 1 by 4 square. Then 1 by lambda 2, second series R 1 by 3 square by 1 by 5 square. Okay, then you calculate, then divide and find out the ratio 1 lambda 1 by lambda 2, and you will get it is 256 by 500 175. So choice A is the correct answer. Okay, you have to do this one. Okay, and this will you will get the result you will get here 1 by lambda 1 is equal to, you will get to 144. Okay, divided 1 by lambda 1 you will get here 7R by 144. Therefore lambda 1 is equal to 144 by 7R. Similarly, by solving this lambda 1 by lambda 2, you will get 16R by 225. Okay, therefore lambda 2 is equal to 225 by 16R. Then you find this one. Okay, so choice A is the correct answer. Next, second question. In any subcell, the maximum number of electrons having same value of spin quantum number is what? Okay, so question number 2, you see total number of electrons in a subcell. Total number of electrons in a subcell is equal to 2 into 2L plus 1. Okay, therefore number of electrons having same spin is equal to 2 into 2L plus 1 by 2, because some spins are clockwise, some spins are anti-clockwise, therefore it is divided same for same spin, it is you have to divide by 2, so you will get 2L plus 1. Okay, so choice for C is the correct answer. Okay, next, for the transition from n is equal to 2 to n is equal to 1, which of the following will produce shortest wavelength? Okay, which will produce shortest wavelength? Question number 3. So for when wavelength is considered, wavelength is directly proportional to 1 by atomic number. Okay, so shortest wavelength, for shortest wavelength, which one is heavier? D, it is your heavier. Lithium plus 2 is having atomic number 3, so it is heavier, therefore it has shortest wavelength. Next, if each orbital can hold a maximum of 3 electrons, the number of elements in second period of periodic table, that is long form periodic table, is what? Question number 4. For second periodic element, okay, the configuration is second period, the configuration is 2s to 2p6. Okay, so if each orbital have 3 electrons, the electron configuration will be what? If each orbital have 3 electrons, then the configuration will be 2s3 2p x3, 2p y3 and 2p z3. So what is the total number of electron? This is 9 and this is 3, that is 12. Okay, so D is the correct answer. Next, the angular momentum of electrons in d orbital. So what is the question number 5? The rule for orbital angular momentum, root over L into L plus 1. Okay, L into L plus 1 h by 4 pi. So for d orbital, what is taken for d orbital? For d orbital, L value is 2. Okay, for s orbital it is 0. For p orbital it is 1. L orbital 2. So put 2 here. So 2 multiplied 3 root over h by 4 5, that is 6 root over 6 h by 4 pi. So you will get which one? 6. Choice B is the correct answer. Okay. Next, what is the maximum number of orbitals that can be identified with the following quantum number? Okay. So for this quantum number, the maximum number of orbital you have to find out, that is 1. Only 1 you will find. That is n L is equal to 1 for p. Question number 6 3p. Okay, and m is equal to 0 for pz. That is pz orbital. Okay, next, calculate the energy in joule corresponding up to light of wavelength 45 nanometer. H value is given. So what to do? You have to do question number 7. Okay, energy in joule. So energy is equal to hc by lambda. H is Planck's constant, 6.63, 10 to the power minus 34. C value 3 into 10 to the power 8 meter per second, or 10 for cm per second. Okay, and lambda is given. Calculate the energy. Lambda is given what? Light of wavelength 45. Okay, if it is nanometer, then 10 to the minus 9. Okay, so by solving you will get here 4.42 multiplied 10 to the power minus 18. Okay, this choice D is the correct answer. Next, the value of Planck's constant is this much. The speed of light is this much. Which value is closest to the wavelength in nanometer? Okay, so question number 8. So lambda is equal to c by nu. Okay, c value is given 3 multiplied 10 to the power 17 nanometer per second, and this value 6 multiplied 10 to the power 15 second inverse. So by solving this you will get 50 nanometer. So choice B is the correct answer. Next, based on equation E is equal to minus 2.178 multiplied 10 to the power minus 18 joule z square by n square. Certain conclusions are written. Which of them is not correct? So you see, you read all these things and C is it is not correct. See, what is C? For n is equal to 1, that is case L, the electron has a more negative energy than it does for n is equal to 6, which means that the electron is more loosely bound in the smallest allowed orbit. Okay, so this portion is correct. this portion is wrong. Most electron is more loosely bound in the smallest allowed orbit. It is the wrong sentence. Okay, so choice C is the Here for choice C is the correct answer. Okay students, have a good day.